Okay, so this is the Unit 15 seminar on applications of trigonometry. Most of the unit guide is going to be based on word problems, but instead of focusing the seminar on word problems, I'm going to just draw the triangles and help you figure out how to solve them. The first part of the Unit 15 guide deals with the special angles. So the special triangles or the special angles that you are going to have to memorize how to draw each of these triangles. That's going to be for the 45-degree triangle, the 30-degree triangle, and the 60-degree triangle. Now, these are not three separate triangles. Fortunately, the 30-degree triangle and the 60-degree triangle can be put together in one triangle, and the 45-degree triangle is all by itself. So, we're going to start off with the special angle 45 degrees. So, obviously, we're still dealing with right angles. So, if I know that my starting angle is 45 degrees, let's call that angle A. What is angle B going to be? What is angle B going to be? We know that the entire angle measure of a triangle is 180 degrees, and we know that this triangle is a right angle triangle, so we have a 90-degree triangle here. So angle B is going to be 180 degrees minus 45 degrees and minus 90 degrees. So what is angle B going to be? Michelle? Good. So this is also going to be a 45-degree angle as well. However, make sure that you highlight that angle A is going to be our reference, our starting point. The reason why this triangle is so easy to memorize is because both of our other angles are 45 degrees. So, when you calculate for a 45-degree triangle, and we're dealing with ratio and proportion here, the opposite and the adjacent are both going to be 1, side length 1. And then when we use the Pythagorean theorem to solve for our hypotenuse, our value of our hypotenuse is going to be root 2. So because this particular angle is my starting point, I'm going to call this my adjacent, and this is going to be my opposite. Now, if you memorize how to draw the triangle correctly, then you're going to be able to extract. Oops. What just happened? Sorry. Of information from this triangle. So let's draw it again. This is my 45-degree triangle. Angle A, this side is 1, 1, and this side length is root 2. We're going to label this my adjacent and this my opposite. And you have to make sure to identify that this is a 90-degree triangle. So my sine, 45 degrees, is going to be equal to opposite over hypotenuse. So it's 1 over root 2. Cos of 45 degrees is going to be adjacent over hypotenuse, which is also 1 over root 2. And tan of 45 degrees, that's going to be equal to opposite over adjacent, which is just 1 over 1, which is equal to the nice whole number 1. So in your textbook, they put all this information into a chart form. It can be overwhelming for students to think that you have to memorize all of these ratios, but it's much easier if you just memorize how to draw the triangle. You'll be able to come up with these ratios on your own. Also very important to notice that for the 45-degree triangle, a nice characteristic of this triangle is that the sine ratio and the cosine ratio are equal to each other. So in your unit or on your test, if they ever ask you, what is a triangle where sine and cosine are equal to each other? You know right away the answer to that is the 45-degree triangle, okay? The good thing about a 45-degree triangle as well is if I have another 45-degree triangle attached to it, and this is also, provided this is a right-angled triangle, it's going to form a nice parallelogram, could be a rectangle, a square, anything like that. So that's another characteristic of this special angle. Now we're going to move on to my special angles 30 degrees and 60 degrees. Now remember, these are all on the same triangle. So draw the triangle nice and big, and this is a right-angled triangle. So I'm going to start with my 30-degree triangle. So if 30 degrees is my starting point, and I'm going to make this my starting point. Angle A is my starting point in blue. So when we're talking about the 30-degree triangle, my adjacent is always equal to root 3. My adjacent is root 3 for the 30-degree triangle. The way I try to remember that, 30 degrees, there's a 3 underneath the radical, and that's how I always remember. This is my 90-degree triangle. My opposite is always equal to 1. And if you use the Pythagorean theorem, if you memorize these two sides and forget the hypotenuse, remember you can use the Pythagorean theorem. C squared is equal to A squared plus B squared in order to solve for the hypotenuse. In this case, my hypotenuse is 2. So if this angle is my starting point, that means that, Diana, what are we going to call this one? Yes, this is going to be my adjacent, and this is going to be my opposite. So before we move on, let's write down all the ratios for my sine, cosine, tan of 30 degrees. And of course, this is my hypotenuse. That doesn't change no matter what. So sine of 30 degrees is going to be equal to opposite over hypotenuse, 1/2. Cos of 30 degrees is adjacent over hypotenuse, so that would be root 3 over 2. Tan of 30 degrees is opposite over adjacent, so 1 over root 3. Notice there is no repetition. Sine and cos and tan, they're not equal to each other for this particular angle. Now, what is 180 degrees minus 30 degrees minus 90 degrees equal to? What angle is that equal to, Lindsay? 60 degrees. So we don't have to draw an entire triangle. We can just highlight that this is my 60-degree angle. And now remember, whenever we change what our starting point is, so this is going to now be my starting point. This is going to be my angle A. So when I change my starting point, is this still my opposite and is this still my adjacent? No. Whenever you change your starting point, you have to relabel the triangle. The only thing that stays the same is the hypotenuse. The hypotenuse is still your hypotenuse. It's opposite the 90-degree triangle, so that stays the same. However, number 1 or side length 1, that is now my adjacent, and root 3 is now my opposite. So, keeping that in mind, we can now come up with our trig ratio for sine 60 degrees is going to be opposite over hypotenuse, so root 3 over 2. We have cos 60 degrees. That's going to be adjacent over hypotenuse, so 1/2. 1 over 2 is 1/2. And tan 60 degrees is opposite over adjacent, so 1 over root 3. Okay, now we're going to play a game of connect the dots. Can anyone